Here we have a characters problem on infinite series. Okay, let's go to the question. Use the sequence of partial sums to determine whether the series converges or diverges. Here we have an infinite series and we have to determine whether the series converges or diverges using the sequence of partial sums. Okay, so the nth term of the series is given by n over n positive 1. So that is the expression given over here. Okay, now according to the question, we have to use a sequence of partial sums to determine whether this series, the infinite series, converges or diverges. So for that, first I'm going to find the first partial sum. First partial sum means like the sum of first one term in the given series. Sum of first one term is nothing but the first term of the given series. For that, we have to plug in n is equal to 1 into the nth term of the series. When I do so, I'm getting 1 over 1 positive 1, which will become 2. So that is I plugged in 1 for n. Okay, now let me find the second partial sum. Second partial sum means that is S2. S2 means like sum of the first two terms. So to find to get the sum of the first two terms, what I have to do is first I have to plug in n equals to 1 over here. So when I do so, I'm getting 1 over 2. Now I have to get the second term because we find the sum of the first two terms. So to get the sum of the second term, what I have to do is I have to plug in n equals to 2 into the nth term. When I do so, I'm getting 2 over 3. Okay, now let me find the third partial sum. So that means I have to add the first three terms. So for that, I have to plug in n equals to 1, then I'll be getting the first term, n equals to 2, I'll be getting the second term, then n equals to 3, I'll be getting the third term, then I have to add all the three terms to get the sum of first three terms. Already we got the first term and second term, that is 1 over 2, positive 2 over 3. So to get the third term, what I have to do is I have to plug in n equals to 3 over here. When I do so, I'm getting 3 over 4. Okay, now let's find the first, the sum of first four terms. That is a fourth partial sum. So for that, the same thing we have to do. Already we know the first three terms. So let me write them. 1 over 2, positive 2 over 3, positive 3 over 4. Okay, now I've added the first three terms, but according to S4, I have to add the first four terms. That is a fourth partial sum. So to get the fourth term, what I have to do is I have to plug in n equals to 4 over here. Then I'm getting 4 over 5. Okay, now I got the first partial sum, second partial sum, third partial sum, fourth partial sum. Okay, now what I have to do is now I have to form a sequence with the partial sums. That is S1, S2, S3, S4. Okay, in this way it keeps going. Now I have formed a sequence with the partial sums I got so far. Okay, so if the sequence formed by the partial sums converges to a finite value, then we can say the given infinite series converges to that same value. So to which the sequence of the formed by the partial sums converges. In case if the sequence formed by the terms of the partial sum diverges, then the given infinite series will diverge. So now we have to identify the sequence formed by the partial sums converges to a finite value or diverges. So how do we have to find that? So for that, we have to look at the pattern over here. So when it comes to the first partial sum, it's just 1 over 2. When it comes to the second partial sum, so it's 1 over 2, positive 2 over 3. Clearly, so the S2, the second partial sum is greater than the first partial sum. So more clearly, in this sequence, the second term is greater than the first term. And one more important thing we have to notice. So here, the first partial sum is just 1 half, and the second partial sum is 1 half positive 2/3. That means some value is added to 1 over 2. So that's why we are saying S2. I mean, the second partial sum is greater than the first partial sum. So moreover, we have to notice an important thing. That is, so the term over here added here is greater than the previous term 1 half. So it is increasing. And also, if you notice the S3, like the first term is 1 half, the second term is 2/3, which is greater than the previous term. And also, if you consider the third term, it's 3/4, it is greater than the previous term. Again, it is increasing at an increasing rate. Okay, now if I go to the fourth partial sum, the second term is greater than the first term 1 half, and the third term is greater than the second term, that is 2/3, and the fourth term is greater than the third term 3/4. So this is also increasing at an increasing rate. So clearly, the sequence formed by the partial sums diverges. So it does not converge to a finite value. So therefore, the given series diverges. It does not converge to a finite value. And also, we can prove this one using the other way. That is, like we can write an inequality Sk greater than k times A. So we can set up an inequality. So with the partial sums, what we got over here, this Sk represents a k partial sum, and A is some constant. So if the partial sums of the given infinite series satisfy this inequality, then we can say that the given infinite series diverges. Okay, usually we check this inequality from the second partial sum, that is from S2. So for that, what I have to do is I have to plug in k equals to 2 over here. So then I'm getting S2, that is second partial sum, greater than, since we plug in k equals to 2, here also I have to plug in 2 for k, then I'm getting 2a. Okay, so what is the value of S2? So here S2 equals to 1 half positive 2 over 3. So the value of 1 half is 0.5 and the value of 2/3 is greater than 0.5. Then what is the value of S2? So when I add 0.5, 0.5, it's just 1. But the second fraction over here is greater than 0.5. So the value of S2 is greater than 1. Okay, so here S2 has to be greater than 2a, then the value of this 2a has to be 1 according to the stuff what we got over here, that is S2 greater than 1. Okay, if 2a equals to 1, then what is the value of a? Clearly a is 1 half, then I'm getting S2 greater than 2 times 1 half. Okay, we have to do the same thing. We have to do the same check with the third partial sum and fourth partial sum as well. Okay, now let's write the same inequality for the third partial sum, that is S3 greater than, since I plug in k equals to 3 over here also I have to plug in k equals to 3, then I'm getting 3 times a, and just now we got the value of a, that is a equals to 1 half. So this 3 times 1 half is 1.5. And already we got the 2 times 1 half is 1. So this is greater than 1. Okay, now when I find the value of S3, it has to be greater than 1.5 so that we can understand that the third partial sum satisfies this inequality. Let's verify this. Okay, now let's get the value of the third partial sum. Already we know that the value of this 1 half is 0.5. The value of 2/3 is greater than 0.5 and the value of this 3/4 is greater than 0.5. So if I add 0.5, 0.5, 0.5, I'm getting 1.5. Since the second term and the third term over here are greater than 0.5, so the sum of these two terms is greater than 1.5. So the third partial sum satisfies the inequality we got over here. Okay, now let's verify this inequality for the fourth partial sum, S4 greater than S4 means this 4 times the value of a is 1 half. So 4 times 1 half is just 2. So that is the value of S4 has to be greater than 2. Let's evaluate the value of the fourth partial sum. We know that the value of this one is 0.5 and the value of 2/3 is greater than 0.5. The value of 3/4 is also 0.5 and this one also greater than 0.5. So when I add 0.5 to 0.5, the 4 0.5s, I'm getting 2. But the 3 of the values are greater than 0.5. So the sum of all the 4 terms, the fourth partial sum has to be greater than 2. So the fourth partial sum also satisfies the inequality. So the partial sums of the given infinite series satisfies this inequality, that is the Sk greater than Ka, so that Sk greater than K times 1 half. So since given infinite series satisfies the inequality Sk greater than K times 1 half, so the given infinite series diverges.